Hello folks, this is going to just be a short video. So because this last month, this is the month of May 2020, and this last month we had an NEO, near-Earth object, pass by. Well, some people are like, well, that just passed by Lar, way out there, yo. Won't hit the Earth. Well, yeah, okay, so maybe it didn't hit the Earth, thank God. And it was estimated to be, I think my memory isn't always that great, because in one of my videos, the one I just did, I said that I think my estimation of a particular impactor, say for instance that the exact impactor would have been, or was, the South China Sea impactor. I'm like, well, I think my memory is right. It's about anywhere from 18.4 to 19.4 kilometers in diameter. Wrong. No, actually, when I finally found my notes, I should have known my notes first before I presented the material. Right. Well, you know, I'm only human too. So the actual estimation, based on the ratio relevant to a meteor crater's impactor of approximately 40-meter diameter for that magnitude, put it at actually at 8.4 kilometer diameter. Now, if we consider the impactor that just flew by our planet, that was, everybody's like, woo, let's go look at it. Well, we can look at it and we can see it. Ooh, that has got to be pretty large there if you can actually see it with the naked eyeballs. And apparently it was like, if my memory serves me well, which it might not, I think they said it was like going to be like a mile long, so it's like this flying cigar. So if that's the case, then we think about the size and difference between the asteroid or meteor, whatever the heck it was, that flew by, flying Volkswagen that flew by our planet here recently. So it's only about 1/5 the size of the South China Sea impactor, which to present, at the best of my opinion, is like the absolute largest and greatest magnitude impactor to have ever struck the Earth. So the biggest one that caused the most havoc on Earth was 8.4 kilometers in diameter approximately. That gives you a pretty good idea of how you can estimate an impactor with the capacity, and I call them world-class impactors. Why? Because they affect the entire planet. And in this instance, it most definitely affected a very large portion of the planet, mostly the northern hemisphere, but entirely the northern hemisphere. Southern hemisphere, maybe not quite so much, because it did impact the Earth north of the equator, and the North Banda Basin primary vortex, I do believe, is north of the equator. Well, this is going to be a kind of like a hiatus sort of a video, because I was talking about electromagnetism and my theories of how electromagnetism works, whether or not it's electromagnetic fields that surround our planet creating the bubble that retains energy or not, really is beside the point. I'm not scientifically established well enough to give any more of an idea of what it is that this particular field of energy is comprised of. It could be something in terms of energy that is similar to the ozone layer is in gas. So, the ozone layer is comprised of certain elements of a gaseous nature, I do believe is what I had looked up. And so this bubble around the Earth, because I don't have any better theories of its construction, I term it to be electromagnetism. It seems to me the most sensible thing. So then after that, we're going to develop and go into things about gravitation, or gravity. Gravity, in its most simplest terms, is is the vacuum of space. It's a very short definition, and that's exactly what I find it to be. We already have mastered gravity. When we vacuum our rugs, we're mastering gravity. Well, what is what is anti-gravity? Anti-gravity is centrifugal force. Hello. So we already figured all that stuff out. We just don't realize it. And so, once we start putting these things together and thinking of our home in the universe to be a little bit less complicated than it is, it might actually start fitting together very well. So this is going to be my hiatus on this particular series of videos, and that is because of this NEO that just passed the Earth. I need to get out the information that I have that I can share with the scientific community that pertains to how do you identify a meteor impact crater outside of the strict criteria, the strict criteria that seems to limit us to only identifying mountainous rings and their central peaks as meteor craters. Well, the moon has that because there's no atmosphere to cause deflection. Earth, on the other hand, has a great deal of deflection with the Earth's atmosphere, and this greatly affects the way the impactors strike the Earth. The Bermuda Rise is the central peak, and theories. Everything I present to you are theories, but the thing is, the scientific community should really consider what it is that I'm presenting, because there is repetitive appearances in these exact same dimensions. So unless we start really reading the Earth for what it's telling us, we're never going to get the idea of how it really operates. And what's really crazy is they're so large, how can you miss it? We're sitting right on top of it. It's very large. It's very easy to read if you let it penetrate your wall of definition and give it something of a characteristic that might be slightly outside of the norm or outside the box. So once we get outside the box, that's what my atlas is all about. It's going to be Gemmell's Meteor Impact Atlas. Whether it's a meteor, asteroid, I don't really care. It's a flying object from outer space, and it strikes the Earth like a munition from the artillery. Same thing. Or a munition from a mortar. It's the same thing. You have high-angle impactors, you have low-angle impactors. Little Tully Wooly was a low-angle impactor that not only did it strike the Earth, but it had a ricochet furrow too. I mean, the largest low-angle impactor that I could ever find. It's the only one I've been able to find that's low angle. Everything else seems to pretty much clobber the Earth right on almost, at these high angles. About I estimated one was about 42 degree angle perpendicular to the Earth's surface. So, that's the kind of crazy stuff. So I'm going into that so that I can hurry up and get that information out there before an impactor impacts. Well, once one of these crazy large size impactors strike the Earth, we're screwed. I might not be left alive. In fact, my computer that has all this friggin' information on it probably won't even exist anymore. So you got to get the information out so that maybe somebody who's left alive might have a clue. I don't know, it's a lot of information. We can lose intelligence, just like I believe we've lost intelligence in the past. So you have all these megalithic structures that we have so obviously built at some point in time in the story of the human epic, as some scientists have referred to us. I think it was a scientist, maybe not, maybe it was just one of those alien theorist guys. But anyway, it doesn't really matter. If the point fits, if the shoe fits, wear it. Put that shoe on the planet because it fits. So we have an epic to the human existence that precedes our current knowledge. And that's because when something horribly major, such as, say, for instance, an impactor like the South China Sea impactor that puts a hole in the planet that makes the planet look like the Death Star, that's a big hole, folks, and that's the kind of thing that's powerful enough to wipe out just about every kind of living creature you could imagine until the Earth begins to thaw into a state of being able to support life in the capacity that we know it today. Again, and then all of those who preceded us in that reign of time had a level of intelligence and had an understanding that we probably lost, and now we're relearning everything that might have already been known. So let's do it before it happens again, where we get knocked back into the dark ages and we start slinging clubs around to try and get our dinners for the day. Living in caves and running away from pterodactyl birds that are big enough to eat us. So, who knows? We want to be at the top of the food chain pretty much for the rest of eternity, and it's kind of hard to do that if everything else grows to be bigger than you are. That's what we have sci-fi movies for. So that's what I'm leading up to, and that's what I'm going to do, is start developing this atlas, and it's going to start with the largest impactors that have ever struck the Earth, primarily in this case the South China Sea impactor, which is possibly one of 4 world-class impactors that were capable of setting the world, not only setting the world into a state of global or worldwide liquefaction, but also causing the North Pole slit along the Atlapac fracture that goes right through the Arctic. And all of that material just landsliding, or in this case it's bigger than a landslide. It's a continental sliding down into down the surface of the Earth toward the equator and westward, for whatever reason, whether it was directed toward the west because of other vortical activity taking place, or if it was driven toward the west like most of our continental masses are driving toward the west due to the coefficient of solar wind pressure drag, in addition to centrifugal force. Okay, so centrifugal force starts at the poles, works its way down to the equator, and when you talk about atmosphere, it goes, basically starts at the equator and ends up going up. But that's because it's being pressed outward up against the extent of the atmosphere, maybe to the ozone layer, and then forced up toward the top, just like centrifuges work, and pushes it up. And then it's also going westward, so it spirals from the Atlantic, it comes in toward the west and goes up, and then in the Pacific it comes toward the west and it goes up. In the southern hemisphere it does just the opposite, but it still goes westward. Okay, well, all that stuff kind of goes hand in hand. And then you got to think about topography to help you understand how the atmosphere is further affected by the terrain of the Earth. Take, for instance, the Himalayas have a very large impact on the atmosphere. So if the Earth was perfectly flat and round, well, you know what I mean by flat. Flat in a round sense. So it's just a smooth ball, like a rubber ball. Okay, and you have atmosphere flowing around it. It would be the perfect atmosphere, but we don't have a perfect atmosphere in terms of that gyroscopic property, because we have the land structures forcing these otherwise normal functions of wind and current into different directions based on the topography. So you also have that same effect in the asthenosphere and the lithosphere beneath the Earth's surface, as instead of it being an atmosphere, it is the molten or the magma area that has the mantle that is primarily, the mantle's deeper of course, but I mean it's all kind of connected. It's all runny, red, hot rock, liquid rock going around. Okay, so that's kind of what we're looking at with a little piece of dust. I don't know if you can see that. If I can get that thing, I don't want to breathe that. I might get COVID-19. Okay, so that's what it is, and remember to like and subscribe to these videos. One of these days I'll hook the right scientist or group of scientists, and we can open up a much larger field of study in terms of tectonics, whether they're vertical tectonics or plate tectonics. Okay, thank you very much, folks, and I'm going to go ahead and end this.